These are 4.8 notes for Algebra 1 on solving systems of equations by graphing. Okay, so far we have learned how to solve systems by using substitution, and we've learned how to do it using elimination. Now today we're going to learn how to do it using our calculator and by graphing. So you need to have your calculator handy to do this lesson, and we're going to just jump right in. It says use the table on the calculator to determine the ordered pair that is a solution to the system of equations. Check in the table using a calculator. Now let's just do a quick refresher on what a solution means. A solution, because in this case it says here's the solution 5, 2. What they're saying is that if I plugged in x for the x in the equation and I plugged in the y for the y in the equation would come out true. Both sides would be equal. So that's what we mean by a solution. So what we're going to do is take this first equation here, y equals 2 over 5x, and we're going to put it into y1 in your calculator. Go to y equals, that's the button up at the top left, and then go to y2 and put the second equation in. Now, once you've done that, you can go to your table and let's plug in the values that you see for these x's. When x is 3, 4, 5, and 6, what are the y's going to be? Well, in the first equation, you're going to get 1.2, and I'm just taking these right off the table in your calculator. Remember, to get to the table, hit second key and then graph, because right above the word graph it says table, and that's using your second key. It gives you what's right up above it. So second graph goes to your table. So we have 1.2, 1.6, then 2, and 2.4. Now let's look at the y's for the second equation, and we have -4, -1, 2, and 5. And so you'll notice on your table that where x is 5, y is 2. So that's a way you could just look at your table to find the answer. But I also want you to see how you can actually do it by graphing. So since you already have these equations in y1 and y2, I want you to just hit your graph button without hitting the second button first, and you're going to get two equations, one that's rather steep and the other one that's less steep, and they're going to have an intersection point. Now, you always want to look, you want to be able to see where the two lines intersect. If you don't see where they intersect, like sometimes when you graph it, it'll look like this on your screen, and you get to the top of your screen, you can't see anything else, then you're going to hit zoom 3 and then enter. Zoom 3 will back it up a little bit so we can see the intersection point. Okay, so you've hit graph, and if you need to, you hit zoom 3. Make sure you can see where the two lines intersect, and then this is what you're going to put in your calculator. You're going to hit the second button and then the trace button. Trace button is up at the top of your calculator. It's one of your hot buttons up there. Second trace, and then you're going to pick number 5 for where it says intersection. And then once you've chosen number 5, you can just punch the number 5 button on your calculator. Or if you take your arrow key down and hit enter for number 5, then once you've picked number 5 and you've actually punched the number 5, or you hit enter for number 5, then you're going to have to hit enter 3 more times. Enter, enter, enter. I personally think it's easiest to just do second trace and then use the number 5 button on your calculator. Just hit the number 5 button. So second trace 5, enter, enter, enter. And when you do that, you'll look down at the bottom and it's going to say x equals 5, and it's going to say y equals 2. And that's how you can get your solution. Okay, let's try it on another one. And before we do this second one, I want you to note that these equations have already been solved for y. If your equation is not solved for y, you have to do that first, because in order to put an equation into y equals in your calculator, you have to have the equation solved for y. So make sure you do that. In this case, they're already solved for y, so that's easy. So on this one, we're going to start by actually graphing it ourselves. So the first equation is y equals x. And so that means the origin is the y-intercept, and it has a slope of 1. We're looking at the linear parent function right there. It's going to just go like that. There's y equals x. Now, y equals negative 2x minus 3. We're going to put a point on negative 3. That's your y-intercept. And then you have a slope of negative 2. And remember, to make it into a fraction, put a 1 under it. So we're going to do negative 2 over 1, 2 over 1, 2 over 1, like that. And there's our slope of negative 2. And we can just look at our graph that we just drew and see that our solution is going to be negative 1 comma negative 1. Now, you can also go to your table and put in these values for x. Go to, remember, to get to the table, you're going to hit second graph. And then we're going to look at where x equals negative 2. And we get negative 2, negative 1, 0, 1. And then on the other one, we have positive 1, negative 3, negative 5. And so we can see right here, this is the place where both the y values are exactly the same. So the solution is negative 1, negative 1. Now, lastly, if you have this equation in y1 and this equation in y2, you can hit your graph button. And when you do that, you will see your graph come out, just like it does on our graph right here. You're going to have go up like this, and the other one's going to go down, and then hit second, trace, 5, enter, 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 and you will see x equals negative 1, y equals negative 1. So now, if you look on the back of your screen, here is another just summary of how to use your calculator. So to solve the equations using graphing calculator, both equations, I already mentioned this, need to be solved for y. And then you're going to enter each one of the calculator's equations into y equals. And you can hit graph, or just so you know, and we've talked about this in class before, Zoom 6 is the normal screen. So if your screen is kind of wacky on your calculator and you want to get it back to normal, just hit Zoom 6. And then if you do not see the two lines intersecting, then you're going to do Zoom 3 enter to get have it back up. So that's just a summary. We've already talked about that on the front. So on number 4, you're going to put the first equation into y1. You're going to put the second equation into y2. And then hit the graph button. Look to see if you can see both equations. If not, do zoom, or I mean, you can see both equations, but we want to be able to see where they intersect. And if you can't see where they intersect, do Zoom 3 enter. Then second trace 5, enter, 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 and you'll have it. Now, what's the problem with this second equation right here? It is not solved for y. It's not solved for y. So we're going to have to do that first. So the first thing we're going to have to do is take the x over. So we're going to subtract negative 1/3 x, and so we get y equals negative 1/3 x minus 1. You're going to have to do that before you can put it into y2. So this one goes into y1, this one goes into y2, and try it with your calculator and see what you get as your answer. So hopefully you did it correctly and you ended up with 11 and 25 100ths and negative 4 and 75 100ths. Okay, let's try number 5. Let's look, are these equations both solved for y? No, they are not. The first one is, but the second we need to take the x over, so we're going to add 1.6x, and so we get y equals 1.6x minus 5.34. Okay, now that we've done that, take your first equation and put it into y1. Take your second equation and put it into y2. Hit your graph button. Then second trace 5. Enter, enter, enter. And when you do that, hopefully you're coming out with negative 2.4 and negative 9.18. And there's your solutions. Bada bing, bada boom. Okay, I want you to try number 6 without my help. Hit your pause button and go through the motions to get number 6. Okay, so as you're trying number 6, I hope you're solving for y. Now remember, we want to take the x over and divide. So subtract 4x and we get negative 2y equals negative 4x plus 4. And then we divide by negative 2. And you get y equals 2x minus 2. The second one, we want to solve it for y, and we get y equals 2x. Now, if you were to plug those two equations in your calculator, I think what you would see is two lines that look like this. And what kind of lines would those be? Parallel. So we have no solution for this equation, for this system of equations, because why? The lines are parallel. And you know how we know the lines were going to come out parallel? Because these two slopes are exactly the same. They have the same slope, but their y-intercepts are different. This one, the first one has a y-intercept of negative 2, and the second one has a y-intercept of the origin. It's 0, 0. So that's why they came out parallel, and there's no solution. Okay, try number 7. Let's solve this equation for y. We want to take the x over, so we're going to subtract x. So we get 2y equals negative x plus 4. How many x's are there right there? I know we don't see it, but there's a negative 1 in front of that x. So we're going to divide by 2. So we get y equals negative 1/2 x plus 2. Now the second equation, we want to subtract 2x. And we get y equals negative 2x plus 5. So now that our two equations are solved for y, put one of them, let's put one of them into y1 and put the other one into y2 in your calculator. Then hit your graph button. And actually, these are both going to have negative slope. One's going to kind of go flat, and the other one's going to go a little more like that. Find your intersection point, and how do we do that? Second, trace, 5, enter, enter, enter. And when you do that, your calculator is going to tell you that x equals 2 and y equals 1. And bam, there you are, you're solved. Okay, on number 8, let's give it a try. Our first equation is already solved for y. The second one we need to solve for y, and it's fairly simple because the only thing we have to do is divide everything by negative 4. y equals a negative divided by a negative is a positive. 12 divided by 4 is 3x minus 2. Okay, now what do you notice? We got this equation and we got this equation. What do you notice about those two equations? They are exactly the same. And if you were to graph them, you wouldn't even be able to tell that there's two lines on your graph. If you hit graph, if you put this one into y1 and this one into y2, you wouldn't have any idea that the other one's graphed unless you made one, like go over to your settings and make it a thick line so that you could see it go right over top the other one. And what happens when two lines are exactly the same and they graph right on top of each other? Infinite solutions. Okay, number 9 says, what is the x-coordinate of the solution to the system of linear equations below? Okay, well, in order to figure that out, you're going to have to solve your equations for y. We want to do this using a calculator. So we're going to take the x over and then divide. So on the first one, we're going to subtract 4.8x. So you get 0.6y. So 6/10 y equals negative 4 8/10 x plus 4. Now we're going to divide everything by 6/10. And what you end up with is y equals negative 8x plus 20 over 3. And you can get this part right here by just using your math fraction button. That's the best way to put it into y equals, using the fraction, not the decimal. Now, let's do the other equation, and the only thing we have to do on it is subtract 3.2x. So we get y equals negative 3.2x plus 2.7. So let's put one of these into y1, put the other one into y2, hit your graph button, second trace 5, enter, enter, enter. And then it says round to the nearest thousandth. That means go out 3 decimal places. So I want you to try and figure that out on your calculator. See what you get. Because all you have to do is write the x value down on this one. It doesn't say put the y, just the x. And I hope what you have written down is this. 826 thousandths, or 0.826. Okie doke, let's look at number 10. Okay, it says the PHS soccer team is selling hats as a fundraiser. They contacted 2 companies. Hats Off charges a $50 design fee and $5 per hat. Key phrase. Top Stuff charges a $25 design fee and $6 per hat. So remember, when you see these words per, that is most of the time, 99% of the time, that's going to be your slope. So let's go ahead and write 2 equations for these 2 hat companies. We're going to have 1 equals 5x plus 50, and the other company is going to be y equals 6x plus 25. Because here's our slope, $5 per hat, plus the $50 design fee, and the other one is $6 per hat, and then the $25 design fee. Now, how many hats will it cost the same? So put one of these into y1, put the other one into y2, hit your graph button, second trace 5, enter, enter, enter. Remember, if you don't see them connect, and this particular graph is going to look kind of funky because they're going to be very steep and they're going to be very close, and you're just going to have to wait until you see them intersect. And then second trace 5, enter, 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 and you're going to find out that the intersection point is for 25. X equals 25, so X is going to be your number of hats, and what is the cost? Is $175. Explain when it is cheaper for the soccer team to use top stuff, and when is it cheaper to use hats off. So this one was hats off right here. This one's top stuff. And I think what you'll find, you got to look at your table, and you'll see that, especially if you put hats off in first, that's going to be in Y1, and top stuff will be in Y2. Top stuff is cheaper to begin with. Top stuff is cheaper. It's cheaper with top stuff until when? Until 25 hats. At 25 hats it gets the same. For anything after that, top stuff is more expensive. And then hats off becomes cheaper. Top stuff is more, and hats off is cheaper. Okay, so you can look in your table and see how that pans out. Okay, good. Hope that helps. Using your calculator is a great thing, but you have to solve accurately for Y. If you don't know how to solve for Y, you're going to have trouble using your calculator. Okay, so there's your lesson. Good luck.